The global economy looks enormous. Millions of factories, thousands of ports, hundreds of countries, millions of trucks, ships, railways, pipelines, and warehouses. It feels impossible to imagine the entire system stopping. There are too many routes, too many companies, too many products, too many countries. But global trade does not move through an infinite number of pathways. It moves through a limited architecture. A ship can only travel through certain waters. A train can only cross certain corridors. A pipeline can only connect certain regions. A container can only enter the economy through a port. And a port can only handle so much capacity. The system is global, but the routes are physical. And physical systems create bottlenecks. A narrow strait, a canal, a mountain pass, a major port, a railway corridor, a pipeline junction. Each one can become a choke point, a place where the entire system becomes dependent on a limited passage. This creates a strange reality. The world economy may be worth trillions of dollars, but a significant portion of that value can depend on a few miles of geography, a narrow body of water, a single piece of infrastructure, a limited number of loading terminals. The global economy is vast. Its pathways are not. And when a system depends on a small number of critical routes, geography becomes power.
Every logistics system has a limit. A road can handle a certain number of vehicles. A port can process a certain number of containers. A canal can accommodate a certain number of ships. A railway can carry a certain amount of cargo. And when demand approaches capacity, the system becomes sensitive. A small disruption can create a large consequence. This is the economics of a bottleneck. The value of a route is not determined only by its physical size. It is determined by how many economic activities depend on it. Imagine a road used by 100 vehicles. Now imagine a road used by 1 million. The road is physically the same, but its economic importance is completely different. The same logic applies to global trade. A narrow passage can become incredibly valuable if the alternative routes are expensive, or slow, or politically complicated, or simply unavailable. This creates leverage. A choke point does not need to control the entire global economy. It only needs to control a passage that others cannot easily avoid. The more expensive the alternative, the greater the strategic value of the choke point. This is why infrastructure creates economic power. A route becomes valuable because others depend on it. A port becomes valuable because cargo must pass through it. A canal becomes valuable because it saves time. A railway becomes valuable because it connects two otherwise separated markets. And a pipeline becomes valuable because it moves energy between regions. The infrastructure itself is not always the source of power. The dependency is. Because in global trade, the most valuable position may not be owning the product. It may be controlling the path the product must take.
The ocean covers most of the planet, but ships do not move randomly across it. Trade follows routes, routes follow geography, and geography creates concentration. Certain passages connect major economic regions. They reduce distance, save fuel, reduce travel time, and make trade economically viable. These passages become more important as trade expands. A ship traveling around a continent may need additional days, additional fuel, additional crews, additional risk. A shorter route can create enormous economic value. This is why the world has spent centuries building shortcuts, canals, ports, rail connections, and logistics hubs. The goal is simple: reduce friction, move more goods, move them faster, and lower the cost of distance. But every shortcut creates a new dependency. If a route saves enough time, the world begins to rely on it. If enough ships use it, the route becomes critical. If enough economies depend on those ships, the route becomes strategic. This is the paradox of efficiency. The more efficient a system becomes, the more concentrated it can become. A company may eliminate redundant suppliers to reduce cost. A logistics network may concentrate cargo through the most efficient port.
A shipping system may rely on the fastest route. The result is lower cost during normal conditions, but greater sensitivity during disruption. Efficiency removes waste, but redundancy absorbs shocks. Global trade constantly balances between the two, and the choke point is where that balance becomes visible.
A canal is more than a waterway. It is a shortcut through geography. Before modern canals, ships had to follow the shape of the planet. They traveled around land, around continents, through longer routes. Then infrastructure changed the map. A canal created a connection where nature had not. Two bodies of water became linked. A journey became shorter, a route became faster, and an entire trade system reorganized around the shortcut. This is one of the most powerful forms of infrastructure, the ability to alter the economics of distance. A route that once required weeks may become significantly shorter. Fuel costs fall, transit times decrease, shipping capacity becomes more valuable, and trade begins to concentrate. But the same shortcut that creates efficiency can also create vulnerability. The more the world relies on a route, the more important that route becomes. A disruption can create a chain reaction. Ships wait, cargo is delayed, insurance costs rise, alternative routes become more expensive, and companies begin to compete for limited capacity elsewhere. This is the fundamental paradox of infrastructure. The most efficient route often becomes the most important route, and the most important route can become the most dangerous dependency. The world builds shortcuts to reduce friction, but eventually, the shortcut itself becomes a choke point.
Global trade is not completed when a ship arrives. The ship is only one part of the system. The cargo must be unloaded, sorted, stored, processed, moved, and connected to the next mode of transportation. This is where ports become critical. A port is a transition machine. It connects the ocean to the land, ships to trucks, trucks to railways, containers to warehouses, and global supply chains to local economies. The port is where the abstract concept of international trade becomes physical. A product arrives from another continent and enters a new economic system. But ports have limits. Cranes can only move so many containers. Terminals can only store so much cargo. Roads can only carry so many trucks. Railways can only handle so much volume. When one part of the system becomes congested, the entire network slows. This creates a second type of choke point, not geographic, operational. A port may be located beside an open ocean, but the cargo can still become trapped, because global logistics is not one continuous flow. It is a sequence of connected systems. Ship, port, truck, rail, warehouse, factory, distribution center, retailer, consumer. Every transition creates friction, and every friction point can become a bottleneck. This is why the modern economy increasingly invests in automation, faster cranes, smarter scheduling, autonomous vehicles, predictive logistics, real-time tracking. The goal is not simply to move more cargo, it is to reduce the number of moments when cargo must wait, because in global trade, waiting is expensive.
Some goods can wait. Energy is different. Modern economies require continuous energy. Factories need power. Vehicles need fuel. Cities need electricity. Industries need heat. And entire countries can depend on energy arriving through specific routes. This creates some of the most strategically important choke points in the world. Energy moves through pipelines, tankers, terminals, ports,
and maritime passages. The infrastructure may be distributed, but the routes can become concentrated. A disruption in an energy corridor can affect more than shipping. It can affect prices, inflation, industrial production, transportation, and national security. This is why energy infrastructure is never simply economic. It is geopolitical. The country that produces energy has influence. The country that controls the route can also have influence. And the country that depends on the route has exposure. This creates a three-part system: production, transportation, consumption. Power can exist at every layer. A country may control the resource. Another may control the infrastructure. A third may depend on the final supply. The global economy is therefore connected by more than trade. It is connected by dependencies, and dependencies create leverage. The same principle appears everywhere. A factory depends on energy. A city depends on the factory. A country depends on the city. And the global economy depends on the entire chain. When one critical connection becomes constrained, the effects can travel far beyond the original location.
The world often thinks about trade through the ocean, but global supply chains also depend on land, railways, roads, bridges, mountain passes, border crossings, and logistics corridors. A factory may be thousands of kilometers from a port. The cargo must travel between them, and that journey can create new dependencies. A railway may connect two major industrial regions. A highway may serve an entire economic corridor. A bridge may carry thousands of trucks every day. A border crossing may become a critical gateway. The system is often invisible until it stops. Then the importance becomes obvious. A delayed train can affect factories. A congested border can affect inventories. A damaged bridge can redirect entire supply chains, and a blocked corridor can force companies to search for alternatives. The global economy is therefore built from chains, but chains have a property. They are only as strong as their weakest link. This is why companies increasingly invest in visibility, tracking systems, predictive analytics, alternative suppliers, multiple routes, and inventory buffers. The goal is to understand where the network can fail, because supply chains are no longer just operational systems, they are strategic systems. A company that understands its dependencies can prepare for disruption. A company that does not may discover its choke points only after the system stops working.
For decades, the global economy optimized. Companies searched for lower costs, faster delivery, smaller inventories, fewer suppliers, more specialized production, and more efficient routes. This created extraordinary gains. Products became cheaper, trade expanded, supply chains became global, and companies learned to coordinate production across continents. But efficiency has a hidden cost. It often reduces redundancy. If a company maintains 3 suppliers, it has alternatives. If it maintains 1, it may have lower costs, but greater exposure. If a supply chain uses multiple routes, a disruption can be absorbed. If it uses one highly efficient route, the system may become fragile. This is the efficiency trap. A system becomes optimized for normal conditions, but normal conditions are not guaranteed. Weather changes, geopolitics changes, demand changes, infrastructure fails, conflicts emerge, and new regulations appear. The system that was designed for maximum efficiency may not be designed for maximum resilience. This is why global trade is entering a new phase. Companies are beginning to ask a different question. Not only, how cheaply can we move goods, but how many ways can we move them? Not only what is the fastest route, but what happens if that route disappears? Not only who is our cheapest supplier, but can we survive if that supplier stops operating? The modern supply chain is becoming a risk management system because in a world of choke points, the most valuable asset may not be efficiency, it may be optionality. A choke point is not only an economic location, it can become a geopolitical asset. Because trade creates dependence, and dependence creates leverage. A country positioned near a major route may gain strategic importance. A government controlling a critical infrastructure corridor may gain bargaining power. A company operating essential logistics infrastructure may gain economic influence. The choke point becomes part of a larger power system. This is why global trade routes are increasingly connected to national strategy. Countries invest in ports, railways, canals, pipelines, data infrastructure, and logistics networks. The goal is not only to move goods, it is to shape the routes through which goods move. Infrastructure can create influence for decades. A new port can change regional trade. A new railway can connect markets. A new canal can alter shipping patterns. A new energy corridor can reduce dependence on another route. The physical architecture of trade can therefore reshape political relationships. This is why infrastructure competition is rarely just about construction. It is about future dependency. Who will rely on this route? Who will finance it? Who will operate it? Who will protect it? And who will have alternatives? These questions define strategic power. Because the future of global trade will not be determined only by who produces the most goods. It will also be determined by who controls the pathways through which those goods move.
Globalization created the illusion of infinite access. A product can be manufactured on one continent, processed on another, assembled somewhere else, and delivered to a consumer thousands of kilometers away. The system feels limitless, but beneath the scale, there is structure, routes, hubs, terminals, corridors, and choke points. The global economy is not one giant open space. It is a network. And networks depend on connections. Some connections are ordinary, others are critical. The critical ones carry disproportionate importance. A narrow passage can influence global shipping. A port can influence an entire region. A railway corridor can connect major markets. A pipeline can influence energy prices. A logistics hub can determine how quickly goods move. The infrastructure may look physical, but the consequences are economic. When the route works, trade expands, costs fall, markets connect, businesses grow. When the route fails, the system reveals its dependencies. Prices rise, inventories shrink, factories wait, and distant consumers feel the consequences. This is the hidden architecture of global trade. Efficiency creates concentration. Concentration creates dependency. Dependency creates leverage, and leverage creates power. The most important actor in a global supply chain may not be the company that manufactures the product. It may be the company that controls the route, the port, the infrastructure, the platform, or the physical connection that everyone else needs. This is why the future of global trade will be shaped by more than factories and corporations. It will be shaped by infrastructure, by geography, by strategic corridors, and by the bottlenecks through which the world must move. Because the global economy is not defined only by what it can produce, it is defined by what it can move, and movement requires pathways. The world may contain billions of economic actors, but their goods often pass through a surprisingly small number of places. That is the paradox of globalization. The system becomes larger while its critical dependencies become more visible. And when the world depends on a route, that route becomes power. Nixera, decoding systems, architecting wealth.